Okay, 3-5, proving lines parallel, and I don't know why they have that 3 there, but maybe I messed up. Okay, students will be able to use a transversal and proving lines parallel and relate parallel and perpendicular lines by completing problems as taught. All right. Basically, this whole lesson is the opposite of everything that we learned. We found out before that if lines are parallel, then we have certain angles that are congruent. So now what we're going to find out is if those certain angles are congruent, that means the lines must be parallel. So if two lines of a transversal form corresponding angles that are congruent, then the two lines are parallel, and that's the symbol for parallel. I'll do blue so it shows up a little bit better. So in this situation, if angle 1 is congruent to angle 5, that means that M is parallel to N. Next theorem, if alternate exterior angles are congruent of two lines cut by a transversal, then the lines are parallel. So it says two lines in a transversal form alternate exterior angles that are congruent, then the two lines are parallel. So here, if 2 and 7 alternate exterior, if they are congruent, then these lines M and N must be parallel. If two lines in a transversal, this is theorem 3-6, converse of the same side. Consecutive interior angles theorem. If two lines in a transversal form same side interior angles that are, now this is where it's different. Not that are congruent, but now instead of congruent, they are supplementary. Supplementary. So if those two things are supplementary, then the lines are parallel. So, if you look at our drawing, if 3 and 5 actually add up to 180, making them supplementary, then that means that M is parallel to N. So this, as you can tell, this is pretty obvious, but this is just the opposite of what we've been doing. Okay, if two lines in a transversal form alternate interior angles that are congruent, then the two lines are, you guessed it, parallel. So, once again, 3 and 6, if they're congruent, that means these lines are parallel. That's it. So, a whole bunch of ways to show the lines are parallel. That's mainly what these theorems all say. And they're all just different ways of proving the same lines parallel. That's it. Well, this is what the problem's going to look like. They're going to say something like, find x so that M is parallel to N. So, what would it take for M to be parallel to N? Well, we have angles 2 and angle 6. Well, 2 and 6 are corresponding, so 2 and 6 would have to be congruent. So, set it equal. 8x plus 4 must equal 9x minus 11. Let's do a little algebra. 4 plus 11 is 15, and 9x minus 8x is just x, so x equals 15. That's what x would have to equal in order to make these two lines parallel. Okay. That's it for these pages. Let's go to the next note. Okay, next page here, we got theorem 3.5. Well, it's actually not 3.5, it's 3.9, and this is not 3.6, this is 3.8. I think it was just a typo. What it says in 3.9 here, it says if two lines are parallel to the same line, then they are parallel to each other. So you have Q is parallel to R, and R is parallel to S, so Q is parallel to S. Okay, well, that's all it is. You got two lines that are parallel to the same line, so S is parallel to R, Q is parallel to R, so Q and S must be parallel. That's it. So that's what you say. You say Q is parallel to S. Alright. And it says, theorem 3.8, in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So, here's M, it's perpendicular to T. We can draw that in right there. And T is perpendicular to N, then we know that M and N are parallel. And check this out. This is also because, look, if these two things are perpendicular, then alternate interior angles would have to be congruent. And if alternate interior angles are congruent, we learned on the last page that makes the lines parallel. So that's just another reason why these lines have to be parallel. So we'd say M and N are parallel once again. So we just came up with, in these notes, just basically there were 6 ways we learned to to show that lines must be parallel. What I'd like for you to do is list all the ways that you can to make lines parallel, but I'm going to let you in on a secret. There are actually 7. So try and list all 7. 6 are in these notes. The 7th one is a throwback. So see if you can figure out what the 7th one is. Okay, adios.